We have extra time, so we're looking at the first page on the homework packet. Okay, first of all, your name is on the top. Somebody to read our scenario for us. Guillermo.
Ms. Healy had 12 students in her classroom. Some of the students may have a driver's license, and some of the students may not have a driver's license. Create a table showing the possible combinations of students with and without a driver's license.
Okay, one piece of information that's important up there is 12 students. Could it be possible students blank a driver's license, students blank a driver's license? Okay, so we got to decide what we're putting in column A and what we're putting in column B. What do you guys want for the first column? So with a driver's license, without. Is it possible that all of the students have a driver's license?
No.
Could you have a math class where everybody could drive? Possible. Might not be likely, but is it possible?
Yes.
Yeah, so it could be that all 12 have a driver's license. And so that would mean nobody doesn't in that situation. Is it possible that no one could have a driver's license? So it is possible that no one. Does anybody here have a driver's license?
Ruby.
Ruby. Okay. So it is possible that. Mr. Craig, you drive? Good. Okay. So how many students would that make for the without category? 12. Okay, now here's the only tricky part on this table. What if instead of 12, 11 have driver's license? Then one doesn't. Oscar, what if 10 had a driver's license? 2 would not. Finish that table, please. Come on, man. Finish the table.
Stop it. Aha! Magic. You see that magic right there? I can spell it.
He's a witch.
Oh.
Wow.
Or why is my brain having trouble? 4, 9, 2. I keep wanting to add up to 11, not 12. 3.
Sometimes it's hard for brains.
2, 10, 1, 11. Okay. Now, your attention back up here, my friends. Now, in tables or in charts, it's important to have a title. What should we title this chart?
License.
Driver license. License drivers. No, license drivers.
Okay. And should we say with license? Because there's some drivers I know who drive without them, but I'm just going to put drivers, maybe Ms. Hale's class. Okay. Normally, whatever you put in the left-hand column, it goes along the x-axis. So that's students with. Spelling it wrong. And anything that you put over on the right-hand column, that's the y-axis. Okay, so these are going to plot like ordered pairs. Again, maybe I'm going to do this to myself to remember. 12 is on the x and 0 is on the y. I need some numbers. So 12 on the x and 0 on the y is right here. We're 12 over, but we're not up. And then I need numbers right here. Zero on the x means back over here, but 12 on the y means 12 up. So those are the two intercepts. 11 and 1 means 11 over, 1 up. 10 over, 2 up, and you get the pattern, yes? This would probably be a good example of a discrete graph. Would it be appropriate to draw a line?
Yes.
But discrete, we saw those way at the beginning of the year, were dotted. The patterns align, but these represent drivers. So would it make sense to have 8.5 drivers?
No. That's not.
No. Probably this would be better as a discrete, because you want whole numbered increments of drivers, whole humans in the class. Okay? Yeah, you could think of it in terms of license. They're like halfway to getting their license, but I just thought I'm going to leave them as dots and remind you about the idea of discrete. Okay? Number 1. What does the ordered pair 0, 12 represent in this situation? Again, the first column is the x, and the second column is the y. What do we title those two columns? This 0, what does that tell us? Okay. This 0 is an x, that 12 is a y. In our table, left hand is the x, right hand is the y. So 0 on this side, what does that mean? What does that column represent? Yes.
Students without driver's license.
So what does this 0 mean? Students. If this is the x and the x is 0, so how many have license? So this means no students have a license. And I heard Jerry say this is an intercept. This is the y-intercept. Okay, but I think they were trying to get in the situation, and that was the class and the situation of license. What does the ordered pair 12-0 represent? All. of the students have a license? That's because this is X, and X is the column that we identified as with a license. This is a Y, and Y is the column that we identified as without a license. Okay, 3. Would it make sense to draw a line through data points? Why or why not? What did we say? Would it make sense to draw a line? No. Why?
Because we don't have half a license.
Or half a human. We don't have half a license or half a student. We need discrete whole number intervals. Is the graph increasing or decreasing?
Decreasing.
Why is this the case for this situation? What does it mean, decreasing? The more people who have a license, the fewer people who don't. Okay, in this room, we had 1 student. If 5 of you got licenses, so now we're up to 6, what would that mean about our without total? It would decrease. Fewer of you would have, if we got up right now and lined up the withs over there and the withouts over here, the majority of class would go this way. But if 5 more people got to have a license, the number on this side went down. As one side goes up, the other side goes down. Okay, you can go ahead and, oh, wait, flip the page. This deserves a review, because the last time we had a quiz on it, it was a little iffy, okay? First off, if you have just a tiny little x in there, the problem's easy. X can be 2 possible answers.
4, -4. Right?
Beautiful. The problem comes with something like number 4. It's not so simple. But what you need to do is think about, just like you did 4 and -4, you just need to think about, I could have a positive thing inside that absolute value and a negative thing inside. So here's the positive version. Here's the negative version. That's just like 1 step more complicated than going 4, -4.
Yep.
Okay? We do need to get the x by itself. Here we'd subtract. That's one version. Here we have to distribute first before we can subtract. -1 times x, -1 times 1. Add a 1 to both sides. -1x equals 11. Who remembers how we get rid of that negative? Divide by -1, divide by -1. X equals, what's positive 11 divided by -1? There's your 2 answers. Okay? Good. I'm going to let you, let's move forward. You working on this page, and I'll walk around to help. The rest of your time today can be a jump start on the packet. All right? All right.